This is section 15.1, and we are going to learn about integration. And so it's like we're going to learn to go backwards. So if you have a known rate of change, so you're given the derivative, you can get the function. That's anti-differentiation. It's the opposite of differentiating. It's the opposite of finding the derivative. You're using integration. And so the notation for that is this symbol that looks like kind of a slender S, and that's read the integral of f of x dx. So that tells you that you're giving a derivative there, you're having a derivative, is the big F of x plus c. Now we have to have a c because when you could have any constant added on there and the derivative would still be the same because the derivative of constant is 0. So when we do an integral like this, the answer always will have a plus c at the end. All right, we're going to look at some rules. All right, the first main rule is like I call it the power rule. So if you have the integral of an x to a power dx, well, remember when we took the derivative, the power came to the front and then it went down by 1. Well, here you've got x to the, we're going to add 1 to the power, and then we're going to divide by whatever that number is, and then plus c. So example, the integral of x to the 4th, that becomes x to the 5th, whatever that number is, now we're dividing by it, plus c. All right? Now, another important and helpful rule says if you have the integral of k, f of x, so you've got some number being multiplied by this, you can pull that k through the integral sign and not worry about it. So if we have the integral of 3x squared, the 3 can come through, then we take the integral of x squared, which is x cubed over 3, plus c. Now, there would be a little simplification there. That could end up just being x cubed, but I wanted to show you the rule. Number 3 has to do with e. Now, if you have e to the x, just plain old e to the x, the rule is e to the x plus c. So you don't have much to deal with there. But if you have e to the kx, so anything other than plain old x, then you have a different rule. It's e to the kx, you write the original, divided by the k plus c. So the integral of e to the 3x would be e to the 3x over 3 plus c. All right? Now, number 4 has 2 rules, either a to the x or a to the kx. That's for every other number in the world besides e. So any regular number. So the rule for a to the x, the integral of that, is a to the x over the natural log of a plus c. So if we had the integral of 2 to the x, here's our rule. That's 2 to the x over ln 2, natural log of 2, plus c. If we have a to the kx, so anything other than plain x, you end up having to put that k on the bottom down here. So integral of 2 to the 3x, we still have 2 to the 3x on top. Then we have that k, that number there, 3, ln 2, because it's ln of a, plus c. Integral of x to the negative 1 has its own rule, because if we just used the regular rule, so if we added 1, that gets us to 0, and then divide by 0, that isn't even defined. So the integral of that, of x to the negative 1, or 1 over x, is ln of the absolute value of x plus c. So those are your basic rules that we're going to deal with right now. And let's go look at our problems. I think we have 10 problems in this set, so let's look at those. All right, number 1, the integral of 12 dx. So you could you could do a couple of things. You can pull that 12 through. So if we wrote it as that, then when you integrate 1, you're raising from a constant to just the x. So you get 12x plus c. So anytime you just have a number in here in the integral, you're going to end up with it with the variable x. So 12x plus c. Number 2, integral of 8x plus 7 dx. So this piece, 8x squared over 2, plus, now we just have a constant like we had here, so that's 7x. And so we did simplify here. We have 4x squared plus 7x plus c. Number 3, we have 3 pieces here. So the integral of this, we're going to separate it and do 12x to the third over 3 minus 6x squared over 2 plus, that's a constant, so that's 3x plus c. And then clean it up. That becomes 4x cubed minus 3x squared plus 3x plus c. Number 4, we have 4 terms. We're still doing the very same thing. So 2x to the 4th over 4 plus 10x cubed over 3 minus 5x squared over 2 plus 2x plus c. So we'll clean that up. That becomes a 1/2 x to the 4th plus 10/3 x cubed minus 5/2 x squared plus 2x plus c. And we'll move to number 5. The integral of 3x, parentheses x squared plus 6 dx. There is no product rule or anything, so what you want to go ahead and do is multiply this out inside here. So the integral of 3x cubed plus 18x dx, and then do what we've been doing. So this is 3x to the 4th over 4 plus 18x squared over 2. And I didn't put that step here. This is the final step after it's cleaned up. So 3/4 x to the 4th plus 9x squared plus c. That just was 18x squared over 2. That's how we got the 9. All right, number 6. Integral of 1 over 10x to the 7th dx. You want to rewrite that as 1/10 x to the negative 7. Then we don't have that as a fraction. So the 1/10 could go to the outside. Let me write that out for us. Okay, so I've cleared this up just a little bit here. I pulled the 1/10 through, and then I have x to the negative 7 dx. So I've still got 1/10 out here. Now if you add 1 to the negative 7, you get negative 6, and negative 6 has to go on the bottom plus c. And so the 1's on top, the 10's on the bottom, the negative 6 is on the bottom. So we've got negative 1 over 60, x to the negative 6 plus c. We didn't have negative exponents in the answer, so usually we try to make the answer in the question. So usually we try to go back to the form of the question. So the x to the negative 6 would go to the bottom so that the exponent could become positive. So that would be your final answer there. Let's look at number 7. Number 7, integral of 2e to the negative 0.5x dx. I pulled the 2 through, and now I've got e to the negative 0.5x dx. So the 2's out here. E to the negative 0.5x divided by negative 0.5. Now, if you divide 2 by 0.5, you're going to get 4, and it is negative. So you have negative 4 e to the negative 0.5x plus c. So you can just do that on your calculator. And you can think about it, you're dividing by a half. How many halves are in 2? That's 4. All right, number 8. The integral of 7 over x minus 3 e to the 4x plus e to the 0.4 dx. Let's remember, this is just a number. There's no x there. Now, I thought it might be easier on this one to separate it into different integrals. You don't have to. You could do it the way we've been doing, but they're all kind of different, so I just thought we'd look at it that way. So if you pull the 7 through, you've got 1 over x. Remember, that has its own rule. So that's 7 times the ln of absolute value of x. Minus, pull the 3 through, you've got e to the 4x over 4, plus e to the 0.4 x, because that's just a constant. That's just a number, and we just have to move up one level to x. So when we put it all together, 7 ln absolute value of x minus 3/4 e to the 4x plus e to the 0.4 x plus c. All right, 9, the integral of e to the 8u plus 4u du. Well, two parts, e to the 8u over 8 plus 4u squared over 2 plus c. This can be written as 1/8 e to the 8u plus 4 divided by 2 is 2, 2u squared plus c. All right, number 10, it's listed as kind of a word problem. The slope of a tangent line to a curve is given by f prime of x equals this. Remember, slope of the tangent line is the derivative. If the point 0, 2 is on the original curve, find the equation of the curve. We're kind of working backwards from what we had been doing. We were always finding the equation of the tangent line, and now we're going back to the original. So we're going to integrate this derivative here so that we can go backwards. So the integral is 7x squared plus 5x minus 6 dx. So that's 7x cubed over 3 plus 5x squared over 2 minus 6x plus c. Now, what are we going to do? We need to know what this c is. So if we substitute 0 for x, everywhere there's an x, we're still left with the c, and that would be our y value. That point, 0, 2, 0 for x, that will equal our y. Well, all of those go to 0, and we're left with c is 2. That's not the answer to the question. The question is, what is the equation of the curve? So we rewrite it, this piece, and instead of c here, we will actually plug in our 2. So your answer would be 7/3 x cubed plus 5/2 x squared minus 6x plus 2. And that should get you started on integration in 15.1.